Hi, Rohan. How are you doing?
I'm good, sir. How are you?
Very good, very good. So, today, what do you want to learn?
Sir, today I would like to do like graphing using x-intercepts, like learning how to graph like quadratics with x-intercepts and also learn about the quadratic formula.
Okay. So, you want to learn how do we graph parabolas, basically, which are
Yeah.
represented by quadratic equations and using x-intercepts, you said, correct? Okay.
Yes, sir.
So, can you share with me what kind of things you have?
Yes, sir.
And then we'll go from there. Okay.
All right, sir. I'm just gonna share my screen.
Okay.
You can see my screen, right, sir?
Yes, coming up. Okay. So you are a grade 10 student doing quadratics in Ontario, Toronto, Canada, correct?
Yes, sir.
Fine. So go through the pages. I just want to see what you're doing and then we'll move forward.
Okay, sir.
You want
So,
graph quadratics using x-intercepts, right? Okay,
yes, sir.
let's see the examples and the exercise.
Okay. So this was like related to like using the a x minus r and x minus s, sir. So I
Okay.
think that's what it is.
Mm-hmm.
So like factoring, using factoring
So you know
to
factoring skills. Can you factor? Like if I give you this x squared plus 8x plus 7, can you factor, Rohan?
yes, sir, I can do that. Yeah, I know how to do it.
So skip. Go ahead.
Yeah, like basically like simple and complex trinomials, right, sir?
Yeah, yeah, yeah. You
Okay,
can
yeah,
factor.
then I do.
Okay, so first few are factoring examples, and then here, once you factor, how do we graph it, right? So that is to see, find the roots, find the axis of symmetry. Continue.
So basically, sir, for this one, right, sir, just like having like equation 2x plus 3 equals 0 and then moving it to find out what x is, right, sir?
Correct. These are
But
the
what
x
if your
intercepts.
equation contains fractions? Then how would you do it?
You should use a graph in which you could incorporate those fractions, right? So use like one minimum as half, for example, right?
All right.
It'll be easy for you to locate those numbers. Correct. Continue.
So I'm finding equation from a graph.
Finding the equation from a graph. Okay. Okay. So basically, you're factoring all of them and then getting all the things done. Correct. And then you have communication example, right? Real life situation.
Yes, sir.
Continue.
Like your key concepts like x-intercepts of some quadratic relations in the form y equals ax squared plus bx plus c can be found by factoring. Using a quadratic
Relation.
relation can be graphed by using its x-intercepts. For
Correct.
example, to find the x-intercepts of the quadratic relation y equals x squared minus 2x minus 3, factor and solve the corresponding quadratic equation by letting y equals 0. Okay, I see. And then since the roots of x squared minus 2x minus 3 equals 0 are 3 and negative 1, the x-intercepts of y equals x squared minus 2x minus 3 are 3 and negative 1.
Correct.
So x-intercepts are zeros of a quadratic relation y equals ax squared plus bx plus c are the solutions of ax squared plus bx plus c equals 0.
Right.
The x-coordinate of the vertex is on the axis of symmetry, which passes through the midpoint of the line segment connecting the x-intercepts. Substitute this value into quadratic relation to find the y-coordinate of the
Correct.
vertex. And when the x-intercepts and one other point are known, the information can be substituted into y equals ax minus r multiplied by x minus s to find the equation represented in the relation.
Yes. Okay. So a couple of examples. What I will do here is I'll go through my lesson. I'll teach you all the concepts and then we'll come back and do some questions from your book. Is that okay?
Okay, sir. So I'm just gonna stop sharing my screen.
Yeah, you stop sharing and I'll have my lesson here. So I'll start with basics so that you get all the foundation which you really need to understand all what we're talking about. Is it okay?
Yes, sir.
So can you see my screen?
Yes, sir, I can see it.
Okay. Now, basically, Any quadratic equation can be sketched with a graph which looks like a parabola as shown in the diagram here, right? So you see this figure here? That's the parabola we're talking about, correct?
Yes, sir.
Now this parabola could open up or could open downwards based on the leading coefficient sign, right? So generally, the equation which we're talking about is y equals to ax squared plus bx plus c, right?
Yes, sir.
If a is greater than 0, then it opens up. And if a is less than 0, then it opens down, correct?
Yes, sir.
And this graph is known as parabola. Now let us understand the parabola itself and major characteristics. The turning point is very important. Turning point is called the vertex of the parabola. So we have the vertex there at the turning point. Then the dotted line, which is shown here, is called the axis. It is the axis of symmetry for the parabola. Now the y-intercept is the point where the graph crosses the y-axis, and the x-intercepts are the points where the graph crosses the x-axis, correct?
Yes, sir.
So therefore, to sketch this parabola, we could sketch with these two x-intercepts, the vertex and the y-intercept. Now, I'll actually take you through the parent function y equals to x squared, which is the parent function. If I multiply by a, it gets vertically stretched by a factor of a. If I add something like k, it gets translated up and down. And this is the vertex form in which we could easily sketch parabola using the steps. And what you are really interested in finding is how do we sketch a parabola when we are given an equation, or if we have to write an equation in the intercept form, right? So you are interested in this part. When you are given any quadratic equation, remember one thing, that all equations cannot be factored, right? So we have all equations cannot be factored. Is that okay?
Yes, sir.
So in our examples, we are restricted to the quadratic equations of the form y equals to ax squared plus bx plus c, where we get integers with the property that let me continue from here. Why it is not able- So as I said, all equations cannot be factored. Therefore, we will be restricting ourselves to equations of the form ax squared plus bx plus c, where there is a specific property, which is product and sum, right? So we're looking for two numbers p and q, whose product is a times c, right? And the sum of p and q is b.
Okay, so like basically m times n equals a multiplied by c, and then m plus n is equal to b, sir.
Yeah. So once we get that, then we are going to use this property and then we're going to factor. Is that okay? Where
Yes, sir.
p and q are integers, right? So we write p and q belongs to integers. Is that clear to you? So
Yes,
we
sir.
are
So
getting into those
basically,
kinds of equations, correct?
okay, sir. So basically, like in this one factoring, right, sir? We have to look at the first and third terms to see if they're positive and are perfect squares to factor.
Not a perfect square. If you find a combination so that AC, for example, A times C is, let us say, 4 and 3, 12, right? And B is 7. So 4 plus 3 is 7. You get the idea. Then you can
Yes, sir.
factor. If b is not 7 or something like you could use 4 and minus 3, there could be many combinations. Well, so is this concept clear to you? So we are
Yes, sir.
actually looking into equations where we could get product and some kind of a thing to factor. Okay. Now we'll quickly go through the graphs as such. So I was saying we could actually graph a parabola using standard form. We could graph using the factored form, or we could graph using the vertex form. Correct? We are now going to concentrate on how do we graph using the factored form, right? So if I have this equation y equals to a times x minus x1 times x minus x2, then what are the x-intercepts? The x-intercepts are x1 and x2, right? So these two x-intercepts are known to us then. Is that clear to you?
Yes, sir.
So let me write down here. We have x1 here and we have x2 here. Now, from this, we can find the axis of symmetry, which is the line, which is forms the axis of symmetry, which is given as x equals to x1 plus x2 divided by 2. Is that okay?
Yeah, that's for the midterm. I mean, like the midpoint, right, sir?
Let me write xs, s for symmetry, right? Now, once you know the axis of symmetry, we know vertex lie as it lies on axis of symmetry, which is xs for you, right? So this is axis of symmetry. So vertex will lie on it. How do we find the y point? Plug it in, right? So the value of y will be equals to a times this axis of symmetry minus x1 times axis of symmetry minus x2. So we get the y point, and therefore we get the vertex. Is that okay?
Okay, sir. So basically, for that one, sir, we just have to use our x-intercepts, right?
Yes.
Okay, so we don't have to solve like in depth for each bracket and then just
So you
find it.
plug it in, and find the value, right? So
Okay.
axis of symmetry is to be found. Then easily you can always find the y-intercept by plugging x equals to 0, right? You'll also need y-intercept. Let me write down here y-intercept, and that is you will get by substituting x equals to 0, right? So in that case, what do we get? Y equals to a times minus x1 times minus x2. Is that okay? So you get the y-intercept. So with x-intercepts, y-intercepts, and the vertex, we can now sketch the parabola, correct?
Yes, sir.
So you have the concept. We'll quickly go through the standard graphs. If I have to sketch y equals to x squared, you know it is a parabola, right? You can make a table
Yes.
of values. So take x as minus 2, minus 1, 0, 1, 2, 3, 4. So these are the key values, right? For each find x squared, these points are shown on the graph of y equals to x squared, correct? You can calculate
Yes.
on one side and find the other graphs using symmetry, right? So other graphs are symmetric, right? So you can find the other points, correct? And sketch the parabola. Is that clear to you?
Yes, sir.
Now, if I do a vertical step, basically what really happens is that the graph gets vertically stretched by the factor a, which in this case is 2. So every point is getting stretched by that factor, and it moves upwards. As you've seen, it becomes narrower, right?
Yes, sir.
You will also notice that the first difference, which was earlier, now you can find, you see this, it was like 1357, now it is 2610 multiplied by 2. Let me just show you this. First difference is 1357 earlier, right, from the vertex?
Yes, sir.
1357, that means this step is 1. This means that this step is 1, and then we have 3. 1, 2, 3, and then we have 5 steps. 1, 2, 3, 4, 5. And then we have 7 steps. 1, 2, 3, 4, 5, 6, 7. You see that? That is
Yes,
the
sir.
meaning of these steps. So from the vertex, you go 1, 3, 5, 7 steps to sketch the graph. And that is what is very critical to understand. How the first difference relates to the steps and getting the points without doing much calculation. You get the idea?
Yes, sir.
Once you have the vertex, you can actually go with the steps and then symmetrically get it on the other side and get your parabola. Now, as soon as you multiply this by 2, the steps are 2 times 1, 3, 5, 7. Do you note this?
Yes, sir.
So A is the stretch factor, right? So A is the stretch factor. Well, if it is small, it becomes compression. So basically, it is A times the steps are 1, 3, 5, 7. Is it okay?
Yes, sir.
If A is negative, then it is going to open downwards, right?
Yeah.
Because you multiply by -2, it goes down. The value, which was earlier 4, will now become, let us say, -8, correct? So, A, if it is less than 1,
Then
example
it's
here,
vertically compressed.
it is vertically compressed, as you can see in the graph. So it is good to understand how the graph is going to look like, and we'll get into details soon. And this is what happens when A is negative. If A is negative, in that case, it opens downwards as shown here, correct? Plus,
Yes, sir.
we have a factor. We have a number, plus 8, translated 8 units up. Do you see that? Translated 8
Yes,
units
sir.
up and then opening downwards. So that is because of plus 8 here. Now, we could have plus 10 with -2, so it is going downwards. But these are different examples just to show you how we could actually play around with A, the leading coefficient, and stretch or compress the parabola. Now, let's get to the real thing which you need, and that is, how do we sketch when we are given intercept form, correct? So this form, y equals to 2 times x minus 3 times x plus 1 is called the intercept form, right? Because from here, we get the x-intercepts. Is that clear to you?
Yes,
So
sir.
from the equation, can you tell me what are the x-intercepts?
It would be 3 and -1, sir.
So, okay, so 3 and -1. Let me write -1 first, and then the second intercept is 3. Now, those are the two x-intercepts highlighted here. Can you tell me what is axis of symmetry?
The axis of the symmetry would be
x1
x.
plus x2 divided by 2. So in this case, -1 plus 3 divided by 2, and
1.
you get 1. So you see this axis of symmetry is that x equals to 1. You get the idea. So from
Yes,
the
sir.
x-intercept, mark the x-intercept on the graph, and then x equals to 1 is your axis of symmetry. Now you have to find the vertex, correct?
Yes, sir.
So to find the vertex, what will happen? Vertex
Just
will
put in
be
1.
on the x value of 1. Substitute 1 in your equation 2 times 1 minus 3 times 1 plus 1, which is what? So it is
It
2
would
times
be
2
2
times 2,
multiplied by
which is,
-2 plus 2.
which is
So that
negative
would
8.
be -8.
And therefore, the vertex is at 1, -8. So you mark the point vertex, which is -1 and 8. You get the idea. So that becomes
Yes,
the
sir.
vertex. You see how easy it is? Once you get the vertex, then sketch the parabola. You could also use the steps here, right? Let me show you again, because steps concept is very important. We know the value of A is 2. That means it is going to open upwards, right? And the steps will be 2 times 1,
1,
3,
3, 5,
5,
7.
7, and so on, correct? So if you go from here, you go 1 unit and you go 1 up, right? So 1 to 2, you're going 1 up. Do you see that 1 up?
Yes,
And
sir.
then you go next step and you go,
6, sir.
oh, sorry, first unit 2 up. So first unit is 2 up, right? So instead of -8, this will be at -6, right?
6.
So this y-intercept is at -6. Clear? So easy to
Yes, sir.
calculate. And then, So which is basically, let me write here as 2, 6, 10, 14, and so on, correct? So next step,
Yeah.
go 6 up. Go 6 up and you reach this step. You see that? Then accordingly, you can go up and get the next point is 10 up. Do you see 10 up? Can you correlate?
Yes, sir.
So easily you can, without doing any calculations, plot the points one after the other. Once you plot these points, you know that axis of symmetry is right there. So you go the same distance and mark the other point. You get the idea. Smooth curve, which is a parabola, completes the job. Is that clear to you? That is how you're going to sketch a parabola when you are given the equation in factored form, as in this particular case. Is this clear to you?
Yes, sir.
Correct. Let's move on. Take some more examples in this regard. Here is another example for you. Can you tell me how will you sketch this equation, which is y equals to minus half x times x minus 6? Tell me, how will you sketch this equation?
So first, what I would do is I would have to first find the x-intercept.
What are
So
these?
so the x-intercept is when y is equal to 0.
Right? So you
So
equate
in
with
this
0 here.
case, if we put y as 0, then it'll just be negative half x multiplied by x minus 6. So by doing that, we just would have half x in brackets x minus 6. So if we assume x as 0, then we'll just get 0 and 6.
6 and 0 are two x-intercepts. Now, second step is, this is step number 1, correct? Step number 2, find the, let me write here step number 2, okay? Axis of symmetry.
Okay.
So you add both these. Let me say these are 1 and 2, right? So
Yes, sir.
add 1 and 2 and then divide by,
Divide by 2
so 0 plus 6 divided by 2
6
means 3.
is 3.
So we have axis of symmetry, which is shown here on the graph, okay, whose equation is x equals to 3.
X.
Is it clear?
Yes, sir.
Now you have to find the vertex. Step number 3.
Sub in x equals 3 as your from your axis of symmetry into the equation.
You are right. So we have y equals to minus half, and we have 3 times, let me write 3 times 3 minus 6, right? What do you get?
Yes. You would get y equals in negative 3 over 2 multiplied
9, right?
by negative 3, which would just be 9 over 2.
Negative 3, right? Yeah, 9 over 2.
Or 4.5.
4.5. So this point here is at 4.5. Do you see this?
Yes, sir.
Now you have the vertex, you have the x-intercepts. Now once you have that, you can always join them and get the parabola. If you want more points, minus half, you now know the steps also, right? So what are the steps?
135 multiplied by half.
Yes. So 1357 multiplied by half, and you get your steps. Or plug the values in the formula and get your result. Is that clear to you?
Yes, sir.
So do you understand now how do we sketch a parabola when we are given the equation, correct?
Yeah.
Okay, great. So now with that, I'll end the screen. We can take some questions from your book and then solve. Is it okay?
Okay, sir.
Okay, you can share some questions from the exercise. We'll solve it.
Okay, sir. So I'm sharing 6.3, sir.
Okay. So Rohan, let's pick up an equation and let's pick up any equation, right? So let's take this equation first, which is, let me take this equation. Let me annotate. Which one do you want to take? Let's begin with the very first one. Let's keep it simple.
Okay,
Y equals to x squared plus 5x plus 6. Can you factor this? We're talking about y equals to x squared plus 5x plus 6. 6 is 3 times 2, and therefore we could write this as x plus 3 times x plus 2, correct?
Yes,
so
sir.
From here, we can write down the x-intercepts. So x-intercepts are at x equals to minus 3 and minus 2.
X minus 2.
Axis of symmetry. Axis of symmetry, which we are talking about, is the mean value of these two, right? So add them, divide by 2. So minus 5 by
Negative 5 over 2.
negative
So
2.5. Clear?
yes, sir.
Now you need to get the vertex, right? So let me use another ink for getting the vertex. So the vertex is, plug it in, 2.5. So we have 2.5 plus 3 times 2.5 plus 2, right?
Yes, sir.
Use calculator. Tell me, what do you get? So
0.5.
5.5 times 4.5, right?
Yes, sir.
What do you get?
So 5.5 times 4.5. I get 24.75, sir.
So that is your vertex. So vertex is at minus 2.5. Oh, yeah. Sorry. It was minus 2.5. So I did a mistake. Sorry. Okay, let's go back. Plug in minus 2.5, not 2.5.
Okay, sir.
Yes. Let me make this correction. Minus 2.5. So basically, minus 2.5 means 0.5, and here be minus 0.5. So it is minus
0.25.
That is what you were saying earlier. You're right. Okay. So we have the vertex. It opens upwards. We can now sketch the graph, which is kind of like this, right? So I'm not making a graph paper here, but I'm labeling it. That is important, right? So the vertex here is at a point which is x value of minus 2.5 and y value of minus 0.25. Is that okay?
Yes, sir.
The two x-intercepts, or let me just draw blue lines indicating the x-intercepts, will be basically at minus 3 and minus 2.
Minus 2.
Right? Correct. And somewhere on the right-hand side will be the y-axis. You can always find the y-intercept, which is 6, right? Let me write down y-intercept.
Which is just going to be 6, sir.
Yes. Correct. So, not to the scale, but if my y-axis somewhere here, then this y-intercept is 6, correct? I wanted to write 6, I wrote 8, 6. 6 is there, right? So 6. Is that clear to you?
Yes, sir. So in these equations.
Yeah.
Okay, sorry. And these equations, right? So you can also like change between standard to the vertex form, right, sir, and then just solve it.
Yeah, you could. You could. So
Okay.
let me clear this and let's take a more example. Let's go to, let's say, second question number 2 or 3, right?
Okay, sir.
Move down. Or let's do question number 7. Yeah, move up. Let's do question number 7, right? Let's find the equation from the graph. Yes. Question number 7.
So write an equation in the form y equals ax squared plus bx plus c to represent each parabola.
How will you do it?
So first, what I would do is I will write down my equation in the intercept form. So
Okay.
that's where I would use like negative 8 and negative 2. So from there, I'll get y equals to a in brackets x plus 8 multiplied x plus 2.
Yeah, because we are x-intercepts at x1 is at minus 8 and x2 is at minus 2, right? So we get this equation. Now we are given a point which is minus 7 minus 10, plug it in. So we have minus 10, the y value, a times minus 7 plus 8, and here we have minus 7 plus 2. You get what? You get minus 10 equals to a times 1 times minus 5. And so minus 10 divided by minus 5 is a, which is 2, right? And therefore, we have an equation y equals to 2 times x plus 8 times x plus 2. Is that clear to you?
Yes, sir.
And you can verify that the vertex here is, you can verify your vertex also by substituting the axis of symmetry. What is the axis of symmetry?
the axis of symmetry would be -8 minus 2 divided by 2, so that would
-2
just be
minus 8 divided by
-10,
2,
-5, sir.
-5, right? So this is at -5. Anyway, the question really wants you to expand this. Now you should expand it, right? You can expand it. It is 2 times x squared plus 2x plus 8x plus 16, correct?
Yes, sir.
So 2 times x squared plus 8 and 2 is 10x plus 16. And now you open the bracket and you get your answer, which is, let me write here, 2x squared plus 20x plus 32. Is it okay?
Okay, so
Why?
it'll just be 2.
Just multiply by 2 and you get your equation. Is this clear to you?
Yes, sir. So what you did was you worked backwards, right, sir? So starting to analyze it, and then you found out what A is equivalent to, and then you just input the coordinates, and then you just worked yourself back to standard form, right, sir?
Correct. Okay, let's clear this and take up more examples. Can you move forward? Can you now find the equation for some of the graph? Okay, can you do this? Next one.
All right. B,
Go on.
sir.
B. Tell me now. How will you do this?
So what
equation?
first to do is I will create an equation, an intercepted form equation. So I'll be y equals to a in brackets x plus 5 multiplied x plus 1. Then what
Because
I'll
those are
do
the
is
two
I'll set
zeros.
the equations.
Yes.
Yes, sir.
And now you'll plug in the vertex, correct? Minus
Yes,
3.
sir.
So 3 is y value. A minus 3 plus 5 minus 3. And that is plus 1, correct?
Yes, sir.
And then you get 3 equals to A times 2. And minus 3 plus 1 is minus 2, right? So 3 over 4, but the negative sign is the value of A. Is that okay?
Okay, sir. Wait,
So-
sir, I have a quick question. So when
Yes?
you're doing it, right, sir, you bring the negative still to the other side. You don't change it from negative to positive when doing it?
So when you multiply, you don't, right? You multiply by -4, right?
Yes, sir.
So, yes. So A is minus 3 by 4, right? So you get y equals to minus 3 by 4. And within the bracket, you put x plus 5 times x plus 1, right? You can multiply and do the needful, convert it to the standard form. Is that clear to you?
Yes, sir.
Okay, so that's also done. Let's move forward and take some more examples.
Alright, so just give me a second. I'm just turning my paper.
Sure, sure.
All right.
So you can do question number 6, 7. Let's see what else.
Okay.
Correct. I think let's take question number 12. It has got some fractions here. Can you please
Yes.
read question number 12?
The path of a kicked ball can be defined by the equation x equals to -1 over 35 d squared plus 16 over 35 d plus 36 over 35. So where h is its height in meters above the ground and d is the horizontal distance in meter. Find the d-intercepts.
So when
Sketch
you
the
say
graph.
d-intercept, what does it mean? D-intercept means what?
It,
So the independent variable here is d. You understand?
yes, sir.
So where is the graph touching that axis? So just find d-intercept. So you just factor the d-intercept. So let's do the first part. So how will you do? Tell me.
So first what I'll do is I'll write down the equation. So h equals to -1 over 35 d squared plus 16 over 35 d squared plus 36 over 35. And what I'll do is I'll collect like terms. In this case, all of the same denominator as 35. So what I do is I multiply it all by 35 to just get -1 over 35 to switch all the
Yeah, factor it
signs.
out. So first step, factor, right?
Yes, sir.
Okay. Now, inside term, we are looking for product and sum to factor the inside term, right? So I could write this as -1 over 35. And what do you need? You need product and sum. You need two numbers whose product is We
You
need two
need to.
numbers whose product is, let's say, product P times Q should be minus 36, correct? And the
Yes,
sum
sir.
of the two numbers should be sum
No,
P and Q, that is minus 16, right?
16. Yes,
So
sir.
the two numbers are what?
Negative 18 and positive 2.
Okay, so therefore, we could now complete our factoring. So we have negative 18, x times negative 18 times x plus 2. Is it okay? So
Okay,
that
sir.
gives you two intercepts, x-intercepts, right?
Yes, sir.
So our x-intercepts are at x1 equals to minus 2 and x2 equals to 18, correct?
Yes, sir.
Now remember one thing, that we're talking about word problems where d is what? D is the horizontal distance in meters. Now distance cannot be negative, right?
Yes, sir.
So this is not a valid x-intercept. We are going to use this x-intercept to sketch the graph. However, it is not the valid x-intercept. So the first part is find the d-intercepts. There are two. X1 is minus 2, x2 is 18. However, the value of x should be
It should
greater
be
than
18.
equal to 0, and therefore only one x-intercept will be reported in the answer. Is it okay?
Yes, sir.
Part B. What is part B? Tell me.
Sketch a graph of this relation.
Correct. So we can always sketch this graph. Let me just do a quick sketch here, and let's say we'll sketch it. So what I'm doing here is showing minus 2 as the x-intercept with a dotted line, right? And then going solid. Is it clear to you? So this is
Yes,
minus
sir.
2. Is it okay? And that is 18 for us. Where is the axis?
It would be at 18
So the
minus
axis will
5,
be
8,
at
sir.
x equals to minus
X,
2 plus 18 divided by 2,
which
which is
is
8.
16 over 2. Which is
8, correct? So
yes,
you
sir.
have the maximum value at 8. So plug in 8 and get your maximum value.
Okay, sir.
So calculate. So we get y equals to minus 1 over 35 times 8 minus 18 times 8 plus 2. What do you get?
So y equals to negative 1 by 35, 8 minus 18, and 8 plus 2, sir?
Yes, 8 minus 18 is minus 10, and this is also 10. So easy calculation for us, right?
Yes.
100 over 35 with a positive sign, correct?
Yeah.
What is that? 100 over 35, around 3 something, right? Let me write 100 over 35. So you get the maximum value. You have this dotted point on the other side. So height is shown there and distance in meters. So you can write units, distance in meters, height in meters, and complete your graph. Is that clear to you?
Yes, sir.
Good job. Now part C. Can you please read part C?
Part C states that for what values of D is this relation valid?
Oh, we answered it earlier. D should be greater than equal to 0, right?
Equal to 0. Yes, sir.
But
So that
less
would be
than,
the domain, sir?
but up to 18. So I should actually write this question as something. Now let's clear all this. Is that okay?
Okay,
So,
sir.
so what value of D? So it is from 0 to
18, sir?
18, right?
Yes, sir.
Now, part D.
So at what height was the ball kicked?
So when you want to find the height as ball kick, put D equals to 0, right? So as soon as you
Yes, sir.
put D equals to 0, you get 36 over 35.
Yes, sir.
Next part, can you please read?
How far had the ball traveled when it landed on the ground? So
Yes.
that would be 18, sir, right?
Yes, you're 80 meters. Do not forget units. Is that okay?
Oh, yes, sir.
Do you understand how do we solve such a question? Is it okay?
Yes, sir.
Perfect. Now, let's see. Let's take one more question from our exercise. Go down. Let's see how many questions are there. Right. Okay. Let's do 15. Okay.
15. Okay,
Yes.
here.
Yeah. Read the question, please.
So find the values of n so that each quadratic relation has only one zero, then sketch its graph.
Correct. So what does it mean and how will you do it? Tell me.
So first of all, we have to find the value of n, which is currently undefined. So what I'm thinking of doing is first of all just bringing n to the other side and x to the other side and solving x squared
No, no,
plus
no.
25.
That will not work. So what basically you just can you pull the screen slightly? I'll get more space to write. Okay.
Okay, sir.
Okay, make it smaller.
Okay.
Yeah, that's good. That's good. So let me write down this equation here. We are given y equals to x squared plus nx plus 25, right? We only want one root, right? So 25, sorry. So we know it is a perfect square. See, x plus 5 whole square, right, will work for us. You get the idea.
Yes, sir.
So we want only one root. Only one root means if I have x plus 5 whole square, what do I get? I get x square plus
Plus
2 times
10x
5, 10x plus 25,
plus
right?
25. Yes, sir.
Therefore, n should be equals to 10. Is that clear to you?
Yes, sir.
That is one way of doing it. The second way is, which is a standard way of doing it, is that we have to find what is b square minus 4ac. So this is called the discriminant.
Oh, b squared minus 4ac.
Yes. And if this is equal to 0, then we have one root. So in our equation, we are given y equals to x squared plus nx plus 25, correct? So a
Yes,
is
sir.
1, b is n, and c is 25, right?
Yes, sir.
So what is b squared minus 4ac? Calculate b squared minus 4ac
So that'll
equated
be
to
n
0.
squared minus 4 multiplied by
X squared minus
125.
4 times 1 times c is 25, correct?
Yes, so n
N
squared
squared
minus
equals to
100.
100. So n is equals to plus minus 10. Do you see that? So the value
Okay.
of n can be both plus or minus 10. Do you see how we get it?
Yes, sir.
So note the formula. So the formula here is that the discriminant b squared minus 4ac should be equal to 0. Is it okay?
Yes,
And
sir.
we are talking y equals to ax squared plus bx plus c. Perfect. That is how you're going to do it. So in each equation, you could work this out. This is one way of, this is an alternate way of doing it, right?
Okay, so that is called discrimination, right, sir?
Discriminant.
Oh, discriminant.
That's the name given to b square minus 4ac, correct?
Okay.
You could also use product and sum. You want the same factors, correct? Perfect squares. So you're looking for perfect squares also. So in factoring skills, for example, let me do the question number part C with the third. So you understood two methods, right?
Yes, sir.
Now let's do the third method with the third part, which is y equals to, can you read this? Y equals to what? 16?
Oh, y equals to 16x squared minus 8x plus n.
So we basically want to write this as a perfect square. Now what is a perfect square? A plus b whole square, right? Look at this. Is what? A plus b whole square is a square plus 2ab plus b square, right? Now in this
Yes, sir.
case, we have 16 can be written as 4x whole square. So do you see the first term as 4x
Yes, sir.
square, right? Now the center term is minus 8. So minus 2 times, if I do 4x, then I get 8, right?
Yeah.
So that means actually that times n should be the center term, right? So that leaves only 1 with us, right?
Yeah.
So this time, and in this particular case, I'm writing the last term as, let me, so I get, yes, this is 1 and that should be 1, right? So in this case, I get n equals to 1. Does it make sense to you?
So you're assuming that n would just be 1, right, sir?
Okay, I'm not really assuming. Let me show you how I did it, right? So we have y equals to 16x squared minus 8x plus n, right? So let me rewrite this as 4x whole square, right? And I want to make this square, right? So I write plus square root n squared. Is it okay?
Plus square root n squared.
Center term should be what? 2 times square root n, right? Times 4x. Is it okay? Using this formula.
Okay, sir.
Now, the center term is basically equal to minus 8x, correct?
Yes, sir.
So when will it be minus 8x? Let's equate minus 2 square root n times 4x equals to minus 8x. Minus 8, not x. X is already there. X and x cancel. Minus
Okay.
8. So what is n equals to?
So n would just be minus 8.
Divide by minus 8, which is 1, correct?
Okay, sir.
That gives you n as 1, right?
Oh, now I understand.
You understand? So that is how you could do it, okay? If you have understood, do part B now, which is minus x squared plus nx minus 9. Tell me how will you do it and what is the answer?
So minus x squared plus nx minus 9, right, sir?
Yes, sir. First thing, always factor the negative thing out so that, things become much, much clearer. Is it okay?
Yeah.
Perfect. Now, in last case, n could be plus or minus 1? No. N cannot be? No. Right?
Yeah.
Okay. Now, write down. How would you factor? This is 3 square, right?
Yes, sir. So it just be x plus 3.
Minus 2 times 3 times x, correct? Because this is 3 square, correct?
Yes, sir.
So that means 2 times 3 is n, correct?
Yeah.
Which is 6. Is it okay?
Yes, sir.
So that is how you're going to factor and get your answer.
Okay.
So with that, we are going to end the exercise. I think we have solved all the examples. We have understood how do we factor standard form of the equation by finding the roots by factoring,
yes.
correct? So,
yes, sir. And the roots are just like the x-intercepts, right? In their final form?
Yes. So basically, we started with a standard form of the equation, went to the factored form. So part 1, can you reduce the screen a bit?
Oh, reduce it more, sir?
Yeah, reduce, so that I get more space. Perfect. So we basically said that if I have y equals to ax squared plus bx plus c, I could always write this as a times x minus x1 times x minus x2, correct?
Yes, sir.
That gave us the intercepts, right? And therefore, from here, we have drawn, assuming that a is greater than 1, we could draw the graph like this, where these points are x1 and x2, right?
Yes, sir.
We do get the x's from here, whose value will be x equals to x1 plus x2 divided by 2, correct?
Yes,
sir. We are saying x's as xs. And that helps us to give us a third point, which actually defines a parabola. You can actually sketch this easily. Remember, C is y-intercept, right? So also remember one thing, let me write on this side, y-intercept clearly, y-intercept, okay. Y-intercept is C. Is it okay? Because at x equals to 0, it will be C. So y-intercept will be your next point to look into, and you get 4 points to draw. From the value of A, you could also use steps, correct?
Yes, sir.
From vertex.
And that can work with all the different
A times 1, 3, 5, 7. Is that clear
equations, right, sir? Yeah.
All the equations. Once you incorporate these things on your graph with the x-intercepts and the vertex, you have a very accurate graph. Is that clear to you?
Yes, sir.
Perfect. So we are going to end our session. You can stop sharing now.
Okay,
And
sir.
I'd like you to summarize what we have learned today. So Rohan, can you please summarize our learnings?
So overall today, we learned about the how to solve a quadratic equation using its x-intercepts, learning the part of the quadratic formula, and how we can go between back and forward of each of the different equation styles from standard form to vertex form and working backwards.
Got it. Good. So we'll end our session here and see you next time with more of quadratics. Okay?
Okay.
Bye.
Goodbye,
Have a
sir.
good.
Have a good day.
You too. Bye.